Oh, yeah.
Yeah, I kind of feel like standing. You want to stand? Hi, everybody.
Hi, Eddie.
Hi. For those of you who don't know me, I'm Eddie. I'm a grad student here. And I get the pleasure of introducing Leslie. This is Leslie Dietiker. She's an assistant professor of mathematics education at Boston University. Recently got her PhD at MSU, Michigan State. Her recent research has focused on developing a mathematical storyline framework that we're going to get to, I'm really excited to hear more about today and to see it applied to data, so I won't say anything about it because we'll get to hear it from her. She's a fellow in the Center for the Study of Mathematics Curriculum and with the International Society for the Design and Development of Education, but she's here for their conference up the hill, so we get her. She spent lots of years writing and developing problem-based mathematics curriculum for those of you who are familiar with it, with CPM, College Preparatory Mathematics. And she's a national board certified high school teacher, math teacher, and she taught in public school in San Francisco for 17 years. She's also my friend and a mentor for me. I've known her for a very long time, and I credit her with, in my own development, with the early articulation, early for me in my development, articulation of the idea that all students are smart and all students are curious and learners, and that principle has underlied, is that a word? A lot of, or maybe all of her work in some ways, and her deep respect for students I find very inspiring. So I'm looking forward to hearing her talk.
Like that's my first introduction, you probably blew them all out of the water the first time too. It's so nice to have a good friend introduce you because they seem to know so much. So I'm here to talk a little bit about my dissertation and some more recent work that I've been doing, and I'm going to outline this. Oops. Okay, well let me go ahead and skip the outline and tell you what my inspiration for my work is. I think this kind of sums it up. Is what would be possible if we knew how to design mathematics curriculum and mathematics experiences that would enthrall students as much as something out of literature like Harry Potter. I mean, Harry Potter is just one of many examples where we can say that young kids will stay up overnight just to hear the next installment. And I asked maybe, and I don't mean disingenuously. I really mean seriously. How can we consider ways in which we can think of designing experiences which make students really crave to know where it's going and what comes next? And that, I think, is an important question that doesn't get asked often enough. And what it does is it sends us into thinking of the aesthetic of mathematics, the experience for the individual who is in our classroom and is in some ways being subjected to mathematics. What is their experience, and how can we influence that through design? Okay? And I think that kind of summarizes the inspiration for my work. And as I talk today, I'll give a bit of a background of my framework that came out of my dissertation, and then I'm going to segue into looking at data through this framework that's been my work for the last year. And my thing's not working very well, so maybe I should stand closer. So Netz is a mathematical historian who has been looking at the aesthetic of mathematical sequences, and his work is relevant because he noticed aesthetic differences between the math texts of Euclid and compared those to Archimedes and wondered, what was going on when you read these two texts. They have a very different flow, and they bring the reader in different ways. And they make you think about what's coming differently. And so he compared the mathematical sequences to that of narrative. And he thought about them as narrative stories. And made claims that mathematicians, when making a logical stream of arguments, say making this claim and then building onto that claim and moving on to that claim and so on, make choices. There's no one way to build that logical train of thought between A and Z. And he points out that through looking at the texts of these two mathematicians, both of a very different genre than our today's math texts, granted, that we can see the manifestations of those choices, of which he then says that must have some aesthetic function. And so he came up with this representation for how claims built and connected as the text progressed. This is Archimedes' sphere and cylinder. And he points out how surprising it would be, or it was in reading, when some claim from earlier in the text would suddenly be brought back and become relevant for something that was being proved later. And whereas the diagram for Euclid was much more step-by-step without long loops. So this raises the question, so why might today we look at mathematical stories? Well, Egan, who is a researcher not in mathematics education, but education broadly, argues that story is a very powerful educational pedagogical form. He says that the story form is a cultural universal. Everyone, everywhere enjoys stories. The story then is not some casual entertainment. It reflects a basic and powerful form in which we make sense of the world and experience. And so his argument is that teachers should consider lessons as stories. And if we develop stories for our students, then students will be more attracted to learning. Okay, that's his argument. And it's interesting, though, because when you look at his discussion around mathematics and his idea of mathematical stories, he generally stays within the notion of historical context of math. So his one example of a mathematical story actually is the notion of building a lesson around a historical reason why counting needed to have base 10. Okay, why base 10, might be important. And while I thought that was a very good example. I loved the example. His notion of story became a story about the mathematics and not necessarily a story of mathematics. So I'm still intrigued and pushing harder and saying, well, what would be a story of mathematics instead of a story about? Okay. So Stigler and Hebert also recognized the usefulness of story, and so when they were comparing lessons from the US to lessons from other countries in their video analysis, of the TIMS videos, they said, imagine the lesson as a story. Well-formed stories consist of sequence of events that fit together to reach a final conclusion. Ill-formed stories are scattered sets of events that don't seem to connect. As readers know, well-formed stories are easier to comprehend than ill-formed stories, and well-formed stories are like coherent lessons. So as an analogy, as well as a metaphor, story gets used quite a bit in discussions around mathematics learning. In fact, I was just reading today Smith and Stein's work on the 5 practices. I don't know how many people here are familiar with that, but again, they mention the idea of soliciting student responses and sequencing them to create a story. And so story is kind of a natural metaphor that we draw upon. Now there's other work that's actually also using the notion of math as narrative without actually explicitly saying this. Like Jarosky's work on word problems is constituting it as a genre. And Levin Pym and Herbal Eisenman talk about a text voice, the voice of the author, which is a narrator. And when you have a narrator, then you have a narrative. And Healy and Sinclair's work is about the effects of tasks and how students narrativize their experience. And so in many ways, this idea has been there, but it has never been theorized. So my dissertation then has been around what is a mathematical story and how can we use literary theory to inform mathematics. So mathematical story is basically the way of thinking about content and the content of a sequence, okay? But as how it unfolds as for the reader, basically. In my dissertation, I was the reader. But if I started task A and I moved to task B, something changes. Okay, the mathematics changes. Maybe the mathematical content changes. Maybe the setting changes. Maybe the numbers change. The objects, what I could call the characters, change. But something changes, and as those changes occur over time, there's a myriad of changes of which I can now describe a path, a sequence, through those tasks. And that mathematical experience of me then confronting these changes throughout time is the story. Okay? Now, what I don't mean by story are just story problems. Okay, so story problems are a form of narrative in mathematics texts, I agree, but it's not limited to that. So I almost avoid talking about story problems because I feel like they're almost a little too easy to think about as stories. And I'm actually talking about some of the other content. You know, factoring, for example. How can we think of that as a story? And we're not talking about just descriptions of activities. So it's not about, it's not telling, again, a story of the lesson, okay? It's actually talking about the content that lesson rested on, and then how that progressed. And then also I want to point out learning objectives. So a lot of times when we talk about content in mathematics, the discussion hinges upon these big statements of ideas that are really the outcomes of our stories. So if we would say, for example, the moral of a fable would be, give me one. Give me a.
It's easier to make a plan than to do it.
Oh, that's a nice one. Okay. And so you'd have a story that basically that would be the essence, right? The message of the story, but the story itself is something to get there. And so oftentimes when we talk about learning objectives, we're actually avoiding talking about the story. We're talking about actually the message we want the story to communicate, and not the actual story itself. Okay, so the learning objective is an outcome of the story. It's, and it has a name. It's called the moral of the story, but it's not encompassing the story itself. So I took a narratologist, Ball's framework, who has worked in narrative theory for many, many years and is very, very well accepted, I'll say, in the narrative world. And I said, if I could take what she writes about narrative and map it to mathematics texts, then maybe I'll get somewhere. So I looked at her framework, and she has a system of layers. She says that narrative can be thought of as in 3 layers that are interconnected. So not exactly distinct, but you can describe each one separately. And so the first one is text. And so what composes a text is the media. It's the book, if it's a book, or the movie, or it's the it's a painting, whatever the media is, and it's the narration of that. So the way the story is communicated is its narration, and that's also like the text's voice, and so that would all be in the text layer. The story then is what I just talked about. It's the ordered sequence of events. It's the encountering of it across time. It's the way the information of the story it unfolds for the reader. And it connects the beginning to the end. So the story sequence is really a key element of story. And the fabula is the reader's logical reordering of that sequence. So, for example, in a narrative story, you might be told 2 facts, A first, and then B. As a math person, I have to use A and B, I don't know why. And I might be told A first, and then I'm told B, but from the ideas of which B presents itself, I figure out that B actually had to happen before A. I may learn of it later, but I realize through its telling that it's a flashback and it happened earlier. Okay, that's the logical reordering or resequencing of the story. And that would be, in narrative terms, that's called the fabula. Okay? So it's what the reader does with the story to make sense of it. Okay, and so in today's talk, I'm really going to be focusing on the story layer here. But the fabula is also a very interesting place in mathematics, because that is where a lot of the figuring out of the story works. But we'll look at the story layer here. And then the mathematical story then would be the ordered sequence of mathematical events. Okay, and the mathematical event is defined as a change. It is something that incurs mathematical change. So when new characters are introduced, when new actions occur, when things are, in mathematics we might decompose a shape, for example, a change has occurred. We might dilate something, we might transform it in some way. Those are all changes. And those events then are encountered in a certain sequence, and we call that a story. So talking about that as a sequence, though, says a little about a story. And so, you know, if you ask a young child what was the story that they heard or whatever, they'll go through the entire list. They'll tell you, and then, and they'll just keep telling you that. But of course, in literature, we want students to be able to start talking generally about stories. And part of that is in identifying some key elements. And so in my dissertation, I then focused on 5 elements of stories, of which I feel are critical in terms of describing almost any story. One is, who are the characters? And so in mathematics stories, the objects that we talk about as though they are real, you know, a triangle, would be an example of a mathematical character. 0 was actually a central character in one of the textbooks that I was analyzing. You could have an algebraic expression like x minus 5, a function. It could be a graph. But the characters are those mathematical objects that we deal with in our curriculum. Now, action are those things that we do to those to change them. So decomposing a shape, for example, increasing a number. And action then also is connected to the word act, like in a play where we say act 1, act 2, act 3. Those are marks of change, and you'll see that I use that word too, connected to action. So action denotes change and marks off events, but they can also be called acts. Now, setting is the mathematical representation in which these characters and actions are found. So just as we might have a story that happens in London, and what happens in that story is dictated by the setting of which we place that story. Same thing in mathematics, where we might have a story about functions, but that story is very different if put on a computer screen with graphical representation than when it's in a tabular table form with numbers. Okay, the story, what we can do with a function, what the actions are that we can do, and how the characters, even the qualities of those characters that are prevalent to us, are all shaped by what we can recognize through our setting. Now, we just already talked about the moral, the resulting message. So an example in mathematics might be 2 numbers can be added in any order without affecting the sum. Okay, that would be an outcome of a lesson or a story that we would want students to walk away with. And then plot is the part that I wanted to talk about today. So plot is defined as this dynamic tension between what is known by the reader and what's not known but they want to know. So if you think about anticipation in a story, when you really can't stop reading and you really want to keep going, it's because there's a burning question, something that you really do want to know the answer of. But often you couldn't have that question unless you had some information already. And so generally you also have to have some knowledge that's playing into that desire, okay? And that there's this delicate tension. If you know too much, then you may not have as much need to keep going because you feel pretty good about maybe knowing where it's going, and you kind of like it's obvious, maybe sometimes. And then other times, though, you don't know enough. And so you don't even realize that there's a mystery afoot, and you're kind of lost, and you kind of give up on reading that too, because you possibly don't have enough to grip onto to even formulate the question of what you might want to know about. So there's this delicate balance that happens as you read, that sometimes you're very eager to know, sometimes you're starting to close those questions, and you're starting to find out certain answers that help satisfy that need to know. Okay? If a text only opens questions for you and never helps you answer them, you might get frustrated as well, right? So there's this balance of opening and closing questions. So Barthes is a literary theorist who then, his whole focus is on the pleasure of text. In fact, that's the name of one of his books, The Pleasure of Text. And he introduces 5 analytic codes, ways of talking about how texts do what they do to help a reader have pleasure. I think that's probably the best, that's pretty much how he would say it. And these 5 codes are representative of different elements of the way texts communicate. The hermeneutic code, though, I want to draw attention to, so that's his code for mystery. So whenever a mystery, and he doesn't mean mystery as in detective story, he means like just some question that seems to be emerging that he wants to know the answer to. And so that would be the work of the hermeneutic. The proetic is the work of action. So that is why he calls it ACT, that's why its acronym is ACT. And that work is marking off the things that occur to change the story. And together, those 2 codes right there are what Ball calls plot. Okay, so remember, Ball was my narratologist, and she didn't define plot in her framework. She let Barthes do it for her, so she used Barthes' 2 codes here as her definition of plot. Because if there's a mystery and there's things that are changing, okay, then together those map how that mystery plays out across text. And so Barthes then, within this set of, within these 2 codes then, he introduces what he calls subcodes that then describe the progression from when a question is asked of the text and how it's answered. So he says that, like, for example, questions are within a theme. So a text has some theme that tells you that the story is going to be about that. So, for example, The Wizard of Oz clearly is fantasy. There's going to be a wizard, there's going to be magic, there's going to be some maybe surreal stuff going on. Just from its name, we can tell that it's not going to be a biography, okay? Even though it is about a Wizard of Oz. Okay. A proposal is now is the suggestion of a mystery. So the theme actually tells us what the mystery is going to be about. But the proposal is now in the text where we sense that a mystery is about to happen. It's clues that give us that there is something that's going to happen, and the proposal is an opening to Barthes. And the formulation of a question then is actually when the question emerges in the text by the reader. So it's something in which now we want to know something. How is Dorothy going to get home? And the promise of an answer is when the author makes clear that the story is going to address this. Okay, this is where you can recognize from a text that a detective is hired, someone's going to find out who murdered so-and-so. Okay, that's a promise that you're going to find out. A snare is when the text then puts forth some lie to mislead the reader. This is an intentional misdirection where you believe that you have the answer, or you think that you know how it's going to play out, and then you find out later that was a bold-faced lie. Okay, so the snare is something to obfuscate the answer. Now, an equivocation is it's kind of related, but an equivocation is an ambiguity that allows the reader to be misled. Okay, it wasn't exactly a lie. You can't point to the lie, but it through its ambiguity, allowed you to make a false assumption. And the false assumption then gets corrected later. Jamming is where there's some now signal that the question's not going to be answered. So this is maybe something in which seems to suggest that now what you thought you were going to find out, you're not going to find out. Okay. Suspended answer is a place where the story seems to make a break and turns to some other topic, and you don't know when or if it's ever going to come back to answering your question. A partial answer is where you're making progress on your answer, and disclosure is where you finally learn what the answer is. Okay? So he has these 10 codes basically to describe in narrative terms how the reader confronts the progress from a question and basically till its answer, and certain things that happen along the way. They don't have to happen in this order. They certainly don't all have to happen, right? You might have stories where there's never a snare, or there's never jamming, or whatever. But he's trying to describe the different aesthetic opportunities that narrative have. So what might this look like? So here's Wizard of Oz again. And so in terms of narrative, we can think of it as big questions that you might ask. And this is really in big terms. I decided to do it with narrative because I think it's easy to talk about these codes first with stories that we recognize, and then we can look at a mathematics example. So like, for example, just from the title alone, you might ask, who's the wizard? Who is this Wizard of Oz, and what are we going to find out about him? So we might raise a question and get a promise of an answer. If the book's titled Wizard of Oz, I have a feeling that we're going to meet the wizard. But then we get a suspended answer in the very beginning of the story, because we have this Dorothy who's in Kansas, and a cyclone, we don't have a wizard there. And so we don't know when the wizard's ever going to come in to the story. And so at first I don't seem to have any way of knowing who the wizard is. And so that's why it would be a suspended answer. But Dorothy is told about the wizard after she ends up in what's it called?
Oz.
No.
Oz, right?
In Oz. But not Emerald City, right? Okay, Oz, thank you. And so she's told about the wizard, and she's told that the wizard is great, that he can send her home. So there's a snare there, because now I believe the wizard is actually has magic, okay? And so if you know the Wizard of Oz, then you know at the end there's a disclosure that the wizard does not, in fact, have magic. But we recognize these snares of when Dorothy and the reader is being misled, okay? And so we can map then Barthes' codes to what's happening across a question to try to figure out who the wizard is. Another will be, how will she go home? Will Dorothy go home, and how? And so we get a proposal that something's going to happen to Dorothy. I don't know what's going to happen. When the cyclone hits, I actually don't know that Dorothy is going to be moved to Oz. But I think something's going to happen that's going to need to be addressed. So I don't know the question yet at a proposal. I just know that there's going to be something that's going to upset Dorothy. And then I find out she's transplanted and she needs to get home. And the question is actually introduced in the text. Dorothy says, how am I going to get home? And there's equivocation, because there's a way in which it's left out on whether or not how she's going to be able to get home, or what that even means to Dorothy, and so on. I'm not going to go through all of these, but we can recognize a question through a text and figure out then at the end, she returns to Kansas. We finally learn how she gets home, okay? And so from this example, we can recognize that there's these things called story arcs that basically we can map to narrative, connected to something we want to learn about, how we learn about it, basically, and what kind of conclusion we draw from it. Okay? So that's a kind of a plot 101 there. Now, I'm going to turn my attention now and just tell you about a study that I'm doing around mathematical plot. And this is through a MET Early Career Research Grant. MET is short for Measures of Effective Teaching, and they've, out of University of Michigan, have been collecting video, a massive database of videos in math and English, and I want to say science too. I believe there's science videos. And my study was funded by the William T. Grant Foundation and Spencer Foundation, but the Met Grant was funded by the Gates Foundation. And so my study was actually just to use the video to try to describe the mathematical plots that we can find in math classes. And so I narrowed my focus to algebra lessons to have one consistent variable, if you will. And it is still, my data set was massive to choose from. There were, I think, about 500 videos. Oh no, I'm sorry, 500 sections of algebra that I could choose from, just with 9th grade only considered. And I wanted to know that if I look at the algebra lessons as mathematical plots, what kinds of distinctions can I find among algebra lessons? And I wanted to, one thing that's interesting about the Met video data is that they have a whole bunch of other measures that come with them. And so one of the measures were the student perception survey data. And so they asked students how they felt about mathematics in their classes and how they, how they perceived their teacher, whether or not the teacher cared about them. And so classes were given measures basically based on their students' perception of whether or not they were captivated with mathematics. So I was able to isolate the algebra classes that students rated as highly captivating, okay, and those that were rated low captivating. And so I identified 8 algebra videos. Most of them were high school. I went outside the high school group to get one 8th grade video because of the captivating score allowed it. But but I was really interested in seeing how these two different groups, particularly the high interest group, but also the low interest, might have distinguishing factors in their mathematical plots and how they raise questions and draw them through the mathematical story of a lesson. And in here, the unit of my story is a full lesson. So the teacher launches it somehow, mathematics happens and hopefully connects and changes across time, of which then there's some kind of closure of the story. And if we look at that as mathematical plots, what are the qualities of the plots that I can recognize? So Captivate, these were the 4 Likert questions the students were asked. I thought you might be interested. And the students were not answering these questions based on a single lesson, but instead about the class in general. So that's important to know, that this is a measure of how the students were rating the captivating quality of the mathematics in general across a period of time, not just for one lesson that I rated. So this class does not keep my attention, I get bored. My teacher makes learning enjoyable. My teacher makes lessons interesting. I like the ways we learn in this class. Those 4 questions constituted a Captivate score, and if there were at least 7 students who answered the survey, then they got a captivating rating. And then I also counted controlled for care, because I recognized that if some students felt their teacher does not care about them, they may also then say that the lessons were not captivating for that reason, and I did not want to have my low interest be because of caring and not because of low captivation. So I controlled for caring, so I only counted positive caring and then looked at the high captivates and the low captivates within that group. So 3 researchers individually coded and analyzed each lesson, and then we met together to resolve differences. And one thing is that we randomized the video IDs so that none of us knew which ones were the high captivate and low captivate as we were coding them. And we were quite shocked when we then found out which ones were high and which ones were low. And something I wanted to just point out is that the questions that we identified as those story arcs, so each story arc had a question that was based on, right? How is Dorothy going to get home? Each of those questions were either raised by the teacher or raised by the student, or were implied because of a statement of a goal. They weren't always in question form, but they were goal-oriented, of which then they were then making progress toward the goal. Sometimes we identified something we thought was a question, so we wrote down as we coded, we wrote down the question, but we saw no evidence of ever working toward that question, so we dropped it from analysis. Okay, so the only questions we kept were ones in which then later had another code, of which there was either partial answer or there was some kind of progress. So some of the qualities that we were looking for is what kind of density do these algebra lessons have? So if I looked at Wizard of Oz again, it would be how many codes do I see? Suspended answer doesn't count because there's no progress here, but there's progress here on this question. So this would have a density of 1, where this would have a density of 2. 2-story arcs had progress within that act. Okay? In this act of this story, this would have a density of 3. So we were really interested in the density across the lessons. And we're also interested in the length of the story arc. How long were these story arcs maintained? Across how many acts? Were they held open? That was important to us as well. Were the lessons described in algebra, were they described as very short arcs or very long arcs? Okay, we were interested in that. We also looked at individual codes. These 5 were particularly important to us as representing things that might spur people wanting to know. Okay, so again, our goal was trying to figure out how could we look at an algebra lesson and think about how they might want to know something. So we selected, just for today's talk, I selected 2 cases. One, and they're both high Captivate, high care. Okay, so they were both rated high Captivate by their students, and that means they're in the top 10% of Captivate. So I mean, like I took the top 10 percentile of Captivate and the bottom 10%. And I selected them though because they have very different structures. And their lessons are on not the same mathematics topic, but both on very symbolic dominant discussions. So they were both around symbols. So one was in factoring, and the other was in exponents, how you can change expressions with exponents. Okay? So I'll be brief here, but I'll start with the exponent lesson. I think it might sound familiar to some people here. So the teacher introduces the objective and says she's going to study the law of exponents and gives an example, 7 squared. And then she introduces a series of laws, and each one has an example that she works out for them. So she does the product law, she does the quotient law, and she does what she calls the power raised to a power law. Okay? And then and she works out an example. So these parts of the story raise certain questions. What are the laws of exponents? Is there a law for when the bases aren't the same? That's because of a statement she makes about the fact that these laws only work when the bases are the same. And what if we have different bases but the same exponent when multiplying? Okay, so these questions are born out of the work that she's doing over here. She then does some more laws. So to not get too bogged down here, she talks about the law of a to the n over b to the n, which can be written as a over b to the n. She talks about its reversibility, how you can start from a over b to the n and work backwards. She presents the zero property as anything raised to the 0 is going to be 1. And she introduces negative exponents and explains how a can be written as a over 1 so that we can find a reciprocal of it for part of her work. And so this has some new questions. What's the difference between this and the quotient rule, for example, because of something that she mentions about this case here. How can I write a and a to the negative n as a fraction that's asked? And how do I simplify? So any problem that she poses becomes a question, okay? Because we don't know how long that's going to play out. And then there's a series of questions. So she does a whole bunch, some where she initiates and she solves, and some where she gives students time to solve. But each time, basically, these will be the questions that get raised as formulated questions because they're posed. And when we mapped her lesson, this is the mathematical plot diagram we came to. So one of the laws of exponents gets raised, and there's a promise when she states it as a goal of the lesson that that's going to be answered. And then each act, she's introducing a new law, basically, and so there's progress in understanding what these laws of exponents are. So that's what you see across that first line there. And then these other questions get raised in the meantime, and sometimes they get some progress. Sometimes they're closed right away, and in fact, oftentimes they're closed right away. And sometimes students have some time to work on them, so they're not closed right away, but then they become closed. Okay? So this is a mathematical plot of a law of exponents lesson that we found in the highly captivating group of algebra videos in the Met study. Okay? And of those other measures, down at the bottom here, the average density was 1.42, and the median density was 1, so, because clearly there's, most of them are 1s here. The average story length was almost 2.5, and and most of them were disclosed. In other words, they reached some kind of closure, and only some were left open. Like, we weren't sure in Act 11 if there was ever going to be another law of exponents that was going to be raised. We don't know. And so it was never said, here's our last one, and so that we knew it was over. Okay, so the factoring lesson, this teacher, different teacher, opens the lesson with a review of introducing the term greatest common factor and discusses the prime factorization of two numbers, 12 and 48. And she emphasizes a different way to start the problem, and that you could choose different ways to start it and you'd still end up with the same prime factorization. And she guides the students through an example with 12a squared b and 3a cubed b. So you see they're very symbolic in nature, not too different in some ways. A student suggests 1.5 and 2 as factors of 3. So the student poses this and she ignores it. But that would be an example of a question, well, there was no question, but a proposal that there could be a mystery of something around what counts as a factor. And so a whole bunch of questions get asked from this. What does it mean to factor? That, again, is tied to the lesson objective. How do we factor? And what is the GCF? She poses this one. What are different ways to factor? So, because she mentions that there's more than one way. What's considered a factor? That is raised because of this contribution. Does the GCF have to be one of the numbers? That's raised because of her example here, 12 and 48. 12 is the GCF. And here, 12 and 3, the 3 is also one of the numbers here, the greatest common factor. And so that comes out of a student statement. And then this is an actual question of a student. Why aren't we using 1.5 and 2? Students are then prompted to find more GCFs. And after a time, teacher solicits a solution process. So now, this time, she's looking again for multiple ways of doing the problem. She poses a new problem and tells the students this time they have to find the GCF first. And this time is the first time that the students have seen an expression of more than one term. Teacher introduces now an alternate method. So there's more alternate methods in this lesson. And then she demonstrates this alternate method. So new questions get arisen. Some that are that were posed by the teacher. But one is, are there more sophisticated ways to factor? Because the teacher keeps hinting that when we get to this other part of factoring, we're going to need this. And so she kept mentioning this other stuff that we were going to learn about factoring. And so it seemed like she's hinting that there's going to be some more out there about sophisticated factoring. And then she wraps up the lesson with some guided questions. So she's going to now do these two examples. And she does a demonstration now of division to factor a GCF out. And the students then work on a problem individually, and the teacher reviews the solution. Okay? So this is not a radically different lesson. Okay? So why do we look for the lowest exponent? It's because she said we should. Why do we divide? Because, again, that became a part of the process of factoring. And we're going through this. Let's see. Why does the student ask, why does the GCF go on the outside? Are we always going to be adding? That was another question by a student. And then here's a problem she posed. Okay, so there are a few more questions on this lesson. But when you see the structure of the way in which the questions get addressed across time, you see that these get overlapped far more than in the last lesson. So in this case, many of these questions are raised in an early part of the lesson, but actually are not addressed until much later in the lesson and remain open in many ways. Now, I color-coded these. Red helps you find the question. So for example, in this question here, what is considered a factor was raised as a proposal because that student said 1.5 and 2 for factors of 3, of which does not get addressed right away. But hints that there might be a question around, wait a minute, that those do multiply to make 3. What does get to be counted as a factor? It gets ultimately raised in Act 5 and doesn't get closed again until Act 9. Okay? And so if we look at this, we see that this lesson has a lot more purple. Purples are those proposals that hints at mystery. The promise of answer are the golds. And so you can see on the 2 longest story arcs, there are golds there, that there's a promise. Potentially those are used to maintain that inquiry across the time. And dark green represents disclosure. So you see that there's a lot less dark green in these lessons, or this lesson here, than the last one. And it just got cut off. That the median density here, compared to the last lesson, which was a 1, is now 6.5. So on average, 6.5 of these formulated questions, between 6 and 7 questions, are being addressed in some way in each act. The average length of the story arc is 4.65 compared to the 2.45. But you can see here, only half of the story arcs actually reached disclosure. And in this case, 2 story arcs continued on because it's clear that she hints that there's going to be more development later. And so therefore, we get a sense that there's more coming beyond this lesson. So there's even these questions left at the end of the lesson. So here are the side by side, and you can see the dramatic difference in structure in some ways. Other ways, they're somewhat similar. So in some ways, they both have, at the beginnings, some kind of question that formulates the goal of the mathematics of the lesson that then spans across the most of the lesson, in this case, about half of the lesson. And then there are some punctuated single problems here and throughout, because there are examples in which the teacher's solving. But even with those, the progress of the lesson is still mathematical, whereas here, the questions are all isolated to the particular problems that the students are solving. There's no greater questions that are being solved beyond those in this lesson. Whereas here, these individual problems are working toward answering some of the longer questions that are holding the lesson together. This is a graph that kind of represents the density, the changing density over time. And so you can see in the factoring lesson, the great increase at the beginning and then a gradual decrease, but a later increase here. This lesson also had a later increase. And again, these are just 2 lessons I pulled out of a set of captivating lessons of the group of algebra videos. But it's interesting the distinctions between them. So we can't say that all captivating lessons have these long story arcs. They don't. Some do and some don't. So what can be said? Well, even among algebra lessons with high Captivate measures, there are different structures. And we can say that at least some algebra lessons can maintain a focus on 10 questions at a time. That factoring lesson had at 1.1 act 10 progress on 10 different questions, or as few as 1. Algebra lesson can have multiple questions that can span an entire lesson. That can be said, and the use of the promise might be used to, in those cases, to sustain inquiry. So in those long story arcs, they tended to have a promise of an answer. They also tended to have reposing of the question, so the questions got asked multiple times as well. So further studies that I am pursuing in this line of work, and that is in this video study, I had basically I had only algebra videos. I'd be curious to find out, do geometry videos have different structures? So if I look at the mathematical plots of calculus, for example, would I see very different, or would I see the same set of videos? I'm sorry, the same set of plots. And how can these plots be grouped meaningfully? Like, if those two extremes that we just looked at, if they had characteristics that set them apart with others, then what would those characteristics be? What are the essential characteristics? Another question is, when student interest and motivation is actually tied to the particular lesson, so I didn't have that in this case, but if it were, what would I have done? So if they were actually, if I could pinpoint those lessons that students say are the most interesting for them, then what are the plot features of those lessons? And then I also am curious about how this framework on a whole can actually impact teachers and their plannings of the lessons. So when learning about the notion of mathematical plot, does that make them, enable them to make different choices in terms of how they have the content of the lesson play out across time? So some closing thoughts. This framework basically helps us address an old problem in mathematics. And I feel like this quote actually sums it up. This is a quote from someone who was a student teacher and who was shadowing a student while they were preparing to be a teacher. And they wrote on a reflection, I don't know how they stand it. I couldn't stand it, and I wasn't there for all day. The lessons are so monotonous it makes you crazy. They just sit there and sort of listen or take notes or respond to the same leading empty questions. I just thought with the standards and all the new technology and everything would be better than when I was in school, but it's not. And yet it absolutely has to be. We can't just keep doing the same old thing. And so I feel like the notion of mathematical stories offers math teachers like me some potential heuristics in terms of thinking about mathematics curriculum. These things that people who've written stories and narratives have known for a long time. Like, does the story make sense? That's a good question. What aesthetic experiences does it offer the reader? And how does each event build on what comes before? What is the progress throughout the story? And what would happen if the sequence is changed? And what makes the reader want to keep reading? So to me, I ask, what is the potential if teachers actually thought this way about designing their lessons? So in terms of the framework, when we look at structure, what do different structures, for example, allow us to do in our stories of mathematics? And it also asks new questions of mathematics story, like what might be a love story, for example, in mathematics? Can we think of one that's a tragedy? Okay, and it makes you maybe think about what would that mean in mathematical terms. So I'll end with this quote. The educational achievement is not to make the strange seem familiar, but to make the familiar seem strange. It is seeing the wonderful that lies hidden in what we take for granted that matters educationally. So thank you very much. I look forward to your questions.
We have some time for questions.
You will go ahead, yes.
You were talking about what surprised you and when you were watching the videos on
yeah.
versus not copying. What was that exactly?
Yeah. Okay, so when we ended our analysis and we had all of our plot data all figured out, I opened up the spreadsheet that had the Captivate scores, and we did the mapping back to our code for it. And the videos that we were certain were going to be high captivating were not. Not all of them were high captivating. So in fact, some of the videos that had the most engaged students had the lowest Captivate scores. Yeah, so that shows how the Captivate is not tied to the individual lesson of which we were watching.
The most engaged students as you watch
The video, right,
them being
right,
engaged. I see.
right, where we could see them standing up to go and see when they couldn't see something. I mean, they were physically moving to take part in the mathematics lesson, and yet that one that I'm now just talking about was the lowest Captivate score.
Why do you think that is?
I don't know. I don't know. I don't know if it's like I showed the Captivate answers, and that's what the students said. Part of me wonders if it was a cultural school thing, that maybe, you know, it was a class that had an ethos of, well, we're not really math people or something. I'm not sure if they were communicating that through whether or not they might be a geek if they answered that they liked math or something like that. I'm not sure if that was an element of it at all, because the data doesn't give me any information about that. They were the schools that the videos came from were from 6 large districts around the country. All, you know, most, you know, I would say half of them were urban, but no rural schools. And I know that some were suburban. But beyond that, I don't know. So I'm interested to find out too.
Have you done any thinking about how, or do you have plans? You asked that question about what if you had Captivate scores by lesson?
Yes.
Because that feels like a big thing, right?
Yeah,
like
right.
What happens over the course of a year is really different,
Sure,
right?
yeah. And every teacher could tell you that some lessons work and some lessons don't, right? Some lessons our students walk out saying, oh, this was so fun, and other lessons they, you know,
What a boring day.
yeah, right, whatever. And they don't make any comment. And so, yes, you're right. I think that would make a lot of difference. But I think that it was an important study for me because it really helped me figure out the coding scheme for enacted videos. So it is so much easier to code textbooks, let me just say, because textbooks don't talk over each other, and they complete their sentences largely, and you know, they even bold certain key parts that, you know, draw your attention to it. I mean, there's lots of clues in a textbook. So my dissertation by far was a much easier coding process than in this messy dialogue that happens in school. So it was a very good opportunity for me to play out how does this look in an enacted environment, so that then when I can get those measures in data that would perhaps give us a window into lessons that really, you know, grab students' attention in their minds, what attracts them. We could look at the mathematical plots that did that. Yes?
I was just thinking about like the culture of the students you'd be like kind of trying this out with, in framing your ideas around stories. If you looked at stories from like non-Western cultures and how those relate, and like
Yes,
if
we did.
there
Yes.
are cultures where there isn't such a linear plot progression,
Yes.
and how students might or might not relate.
Yes. Oh, that's true. And in fact, actually, a lot of my literary work or background is in Native American stories. So they have a long culture of trickster stories, and so part of me is very interested in the idea of the narrator who will mislead, right? And so that's why I was interested to find out if snares would, if we'd find snares, and we did. Not in these 2 videos. We did find some snares. So yeah, I feel like there's more work to be done in terms of theorizing this, but I appreciate your statement because I agree. Yes.
I think it's very fascinating. When you looked at the videos, did you take into account, was it mainly lecture-based or was there inquiry activities? I'm just very curious.
Yes, so in the 2 lessons that I presented here, they were pretty much lecture-based. The second lesson, the factoring one, did involve the students more by soliciting more from the students than talking to the students. The students said a lot more in that factoring lesson than in the exponent lesson. In the exponent lesson, our way of structuring our transcript actually broke down because the teacher talked so long that we had to like reformat the screen because we expected it to be teacher, student, teacher, student, you know, whatever, and students hardly ever spoke.
Because I read the Stigler book and it was wonderful, and they talked about contrasting styles in Germany and Japan.
Yes.
And it seems like in Japan they do a lot more inquiry.
Yes, that's true. And we did have one lesson that I could characterize as inquiry, and it wasn't here.
Did it get a high Captivate score?
No, it did not. And I can't really say it was an exceptional lesson either. I mean, it was, but I would say it was more inquiry-based. Yes. See, I would love to look at lessons It's really hard to find a scheme that will help you find those. It's like a needle in a haystack in the Met videos. You got 5. You have how many classes did I say? Once you controlled for care, I think I had 200 and something classes that said that their math teacher cared about them. Of those, they had 4 videos in each of those, 4 to 8 actually. So I had quite a sizable number of videos, of which then I used the Captivate measure to help me locate the videos. But there may have been some really good gems in the middle there too, where those I didn't see them. It's a lot. Yeah, yeah.
I'm wondering about the. I feel like when I think about this framework in relationship to a reader and a book, I feel like the framework helps me think about the reader's experience with the text, not the text itself.
Right.
And I'm wondering about how, I don't know even exactly what my question is, but how that maps into a classroom, like whose experience are you attending to?
Right, it's our experience as researchers. I mean, we can only tell the story as we perceive it from this video, right? We use the discourse of the teachers and students basically to inform our story, but it is our experience. It was the questions that we could recognize emerging. So the students may have different questions, right? Well, some of them asked it. So, I mean, their questions did emerge in our data, but some may have bought questions that didn't get asked.
It sounds like it's a fascinating thought experiment to me, whether like issues of access or like differential engagement and achievement, we might learn something new about them by thinking about, I don't know what this would look like in study, but thinking about the maybe different stories that students are experiencing in interacting with the same lesson, and maybe lessons in which there's a wider variation among student experience than in lessons where students more uniformly see the same story. Do you know what I mean?
Right. So there's words for that. And Barthes actually has, in his framework, he's very interested in this. He calls texts that invite the reader basically to write the story with with the author, basically, as writerly texts. So it's where the reader is writing the story by imagining, building, so they're inspired to think about the story and construct it. Whereas the texts that really tell you everything the way it is and to minute details and don't leave anything to your imagination are readerly texts. Okay, so they're texts where really they relegate the reader to only reading passively and not engaging with the material.
Have you applied that?
Yeah, that is that is his framework. And so in fact so you'd see much more variance in terms of the interpretation of the story when there's lots of going on in terms of the questions. There's lots of questions that emerge from the text. Because each one of those invite you to then imagine what the answer is.
Where do you see application in younger grades?
Oh, that's interesting. So my first enacted study actually was on a 2nd grade lesson, and it was because a class was studying symmetry, and I was there videotaping, and there was a lot of just very nice activities. The students were folding, and they were cutting things in half, and so on. And there was some discussions going on about why certain things had more than one line of symmetry, and so on. And suddenly the teacher just did such a basic act of just introducing some new shapes, and the students gasped in this amazing way, of which then the students who were relegated off to the side on some computer or some worksheet or something had to get up and walk over to find out what was so interesting to the rest of the class. And I studied the plot here. I was really drawn. I mean, there was an example of one in which there was a remarkable change aesthetically that I can observe in the students. And it was all based on the questions that were leading the students. This one was based on an equivocation that she never said that every shape has a line of symmetry, but she allowed the students to assume it because of the way that the tasks all built upon each other, that all had symmetric shapes. So therefore, because of that, when she then introduced some shapes that did not have lines of symmetry, it was a rude awakening. And so that was a moment in which just a 2nd grade classroom had had an experience that then the last 20 minutes of her class, not one student like left the attention of that lesson. It was pretty amazing. So I think that elementary teachers have a real interest in stories as well as being teachers of reading and using a lot of stories in their classes. So I feel like this framework offers them a way of looking at coherence and ways in which mathematics changes across time.
Any other questions? All right. Thank you, Leslie.
Oh, you're
Great
welcome.
talk. It
Thank
looks like
you.
you'll have time to get to your reception after that.